Okay, some would consider this not to be the most elegant solution because we're first going to solve for time t and then use that to find the distances that each train travels and add them together. So here's a diagram illustrating the situation. City 1, train E, traveling this way, 70 kilometers per hour, using d sub e to represent the distance that train E travels. And over here we have City 2, train F leaving this way, heading in the opposite direction, hopefully on parallel railroad tracks instead of the same railroad track, at 82 kilometers per hour. And we're told that this red distance is 18 more than the blue distance. So I can say d sub F equals d sub E plus 18. So what I'm doing is jotting down some stuff that I know and seeing if I can end up with some equations that are equal to each other. So we're going to use distance equals rate times time. The rate of train E is 70 kilometers per hour, and we're letting t be time, so d sub E could be represented by 70t. And d sub F, which is d sub E plus 18, equals rate times time, 82t. So what we're going to do is substitute 72 into this equation, 70t into this equation, and we'll have one equation involving t, substitution method. So 70t plus 18 equals 82t. We solve that for t and we get 1.5 hours. That doesn't answer the question, but it allows us to solve for d sub E and d sub F. d sub E is 70 times the time, 105. d sub F is 82 times the time, 123 kilometers. Add those together and you have the total distance, because this distance adding together gives you the total distance. Okay. Now, quickly, I'll take you through maybe a more elegant solution. If we let x equal the distance that train E travels and x plus 18 represent the distance that train F travels, then we can come up with an equation involving d and x. Add these together and you get d, 2x plus 18. So x equals 1/2 d minus 9. That's this distance right here, 1/2 d minus 9. And x plus 18 is 1/2 d plus 9 because we add 18 to this guy. So here we have expressions for the distances traveled by each train. And if distance equals rate times time, time equals distance divided by rate, and the times are equal. They both leave at the same time, and when they meet, they've traveled the same amount of time. So here's the time for train E, distance divided by rate, and over here's the distance, or the time rather, for train F, its distance divided by its rate, and those times are equal. If you solve that equation, perhaps by cross multiplying, you end up with this equation. Get the terms with d on the same side, that gives you 6d over here. Transpose this -9 plus times 82 to the right side, 9 times 82 plus 9 times 70 divided by 6. Guess what? You get the same answer. So some would say that's a more elegant solution because we set up the equations involving directly what we're trying to find. No intermediate variables. Okay, there you go. Hope that helped. If you have any questions, post a comment.